Hello everybody, welcome back. So today we want to look at joins and we can get started. Now joins are used to retrieve data from two or more tables based on the logical relationship between the tables, and it defines the manner in which two tables are related in a query by specifying the column from each table to be used for the join. A typical join specifies a foreign key from one table and its associated key in the other table, specifying a logical relationship such as equals, not equal, to be used in comparing values from the columns. Joins can be specified in either the from or where clauses. The syntax of the join statement is as follows. We write select, then the columns which we wish to retrieve, then from table A as alias, join table B as table B alias on. Then you specify the columns which are common in table A to that one in table B. Okay. Now let's look at this. Consider that you want to list employees' first name, last names, and their job titles from the human resources schema, that is the employee table, and the person schema in the person table in the person schema. To extract this information from the two tables, you need to join them based on the business entity ID as shown in the following code snippet. We copy this and switch over to the query window. Okay, all done. Now you can save your work. We highlight this, then we click on execute, and we can see we get the details here. Now I modified the query a little bit. I joined the first name and the last names, but everything else remains the same. We move right on. So these are the results as you can see here. The only difference is that I concatenated these two. Okay, inner join. Now, an inner join is formed when the records from two tables are combined only if the rows from both tables are matched based on a common column. The syntax of the inner join is given below. We select the various columns from the various tables. Then you write inner join table B as table B alias. Then you specify the common column between these two tables. Table A alias and the table B equals table B alias. We have this example here, so please highlight this, copy, and let's meet in the query window. Now if we look at this query, you notice it's essentially the same like the top query. The only difference being that I've written it now exactly the way it is in the slides, and I've added the word inner join. If you look at this comment here, we noted that when working with joins, the inner join is the default join. We're actually going to get identical results, okay, if you execute. You notice here we had 290 rows. If I highlight this top query and execute it, you notice we're still getting the same number of rows, okay? So kindly don't forget this point. Okay, we move right along. Now we have the outer join. Now outer joins are join statements that return all rows from at least one of the tables specified in the from clause, as long as those rows meet anywhere or having condition of the select statement. The two types of commonly used outer joins are given below. We have the left outer join and the right outer join. We start by looking at the left outer join. Now, the left outer join returns all the records from the left table and only matching records from the right table. The syntax of an outer join is given below. Select columns or the column list from table A as its alias, left outer join table B as its alias. On, you specify the common column between these two tables. Consider that you want to retrieve all the customer IDs from the sales customer table and order information such as ship dates and due dates even if customers have not placed any orders. Now, since the record count would be very huge, it is to be restricted only to those orders that are placed before 2012. Kindly highlight this, copy, and let's meet in the query window. Now, the purpose of the query is given here, and we are going to highlight this and execute it. Okay. Now you can see from these results, we are actually getting details of the customer ID whether these customers have any corresponding orders or not. Okay, we move right along. So this is what we have. Now the right outer join. Now the right outer join retrieves all the records from the second table in the join, regardless of whether there is a matching data in the first table or not. And the syntax is given here. Select then the list of columns from the left table name as table A, then the alias of table A. Right outer join table B as its alias, then you specify the common column between these two tables. Now, consider that you want to retrieve all the product names from the product table and all the corresponding sales order IDs from the sales order detail table, even if there is no matching record in the products in the sales order details table. The following code snippet achieves this by using a right outer join. Now, let's highlight this, copy, and let's meet in the query window. All done. Now, the purpose of the query is given here. We highlight this. And we add the semicolon. Now we highlight and we execute it, and you can see what it is that we have here. We have about 121,555 rows. You can see some of these products don't have any sales order ID, and some of them they have the sales order ID. Okay, we move right on. Self-join. Now, a self-join is used to find records in a table that are related to other records in the same table, and a table is joined to itself in a self-join. Consider that an employee table in a database named Sterling has a column named Manager ID to denote information for managers whom employees are reporting to. Assume that the table has the appropriate records inserted in it. A manager is also an employee. This means the manager ID in the table is the emp ID of an employee. For example, in the table below, Annabella with emp ID ARD 36,733F is an employee, but Annabella is also a manager for Victoria, Pale, Kala, and other employees as shown in the following figure. Okay, so we're looking at Annabella. Okay, and you can see now she doesn't have a manager ID. But now, if we look at somebody like Victoria, okay, you can see her manager's ID is given here. It's the same as that of Annabella, okay. To get a list of the manager names along with their other details, you can use a self-join to join the employee table with itself and then extract the desired records. And we have this given here, okay. Now, if you are to execute this query, this would be the results of executing this query. Now, we don't have this table, that's why I'm not going to execute this. We move right along. The merge statement. Now, the merge statement allows you to maintain a target table based on a certain join conditions on a source table using a single statement. You can now perform the following actions in one merge statement. You can insert a row from the source if the row is missing in the target. You can update a target row if a record already exists in the source table. You can delete a target row if the row is missing in the source table. For example, assume that you have a products table that maintains records of all the products. A new products table maintains the records of the new products. You want to update the products table with the records in the new products table. Okay. Now, the new products table is the source table and the products is the target table. The products table contains a record of the existing products with the updated data and new products. And the following figure shows the two tables. Okay. Now, we are going to create these tables very quickly. And the statements to do this are given here. Now, we have the statements which are going to create the two tables. The first one is the products table. The other one is the new products table. Okay, and then you insert items into these tables. These are the statements to insert the records into these tables, and then we have the two statements which are going to display the contents of the two tables. Okay, we highlight this all the way up to where we are creating the tables. I'll hold down my shift key, then click. Now, before we execute this, you make sure you are in the correct database. Make sure you're in your CastDB. So I'll come here and select my CastDB. then click on execute, and you can see we get the results of the two tables here. Make sure you save your work. Okay, then let's see what they want us to do. So we have these two tables and the records in them. Now consider you want to do the following. The first thing we want to do is to compare the last and first names of the customers from both source and target tables. You update the customer information in the target table if the last and first name match the you update the customer information in the target table if the last and first names match. Insert new records in the target table if the last and first names in the source table do not exist in the target table. Delete existing records in the target table if the last and first names do not match with those in the source table. The merge statement also allows you to optionally display those records that were inserted, updated, or deleted by using the output clause. The syntax of the merge statement is given below. We have merge, then the target table using the source table, and then you specify what happens on the merge condition. When merged, then update set column 1 to the value, column 2 to a given value, all the way up to the given columns. And when target not matched, then insert column 1, column 2, then you specify the values. When not matched by source, then delete. Then we have the optional output action. Okay, where the target table is the table where the changes, where the target table is the table where changes are being made. The source table is a table from which the rows will be inserted, updated, or deleted in the target table. Match conditions are the join conditions and any other comparison operator. Matched true if a row in the target table and the source table matches the match condition. Not matched returns true if a row from the source table does not exist in the target table. Source not matched returns true if a row exists in the target table but not in the source table. Output, this is an optional clause that allows you to view those records which have been either inserted, deleted, or updated in the target table. And please note that the merge statement is always terminated with a semicolon. Okay, let's look at this example. Now make sure you highlight this. Okay, copy, then let's meet in the query window. This is the expected output. Okay, all done. We highlight the purpose of the query, or this merge statement is written up here. We are going to highlight this, and after highlighting, we execute it. And you can see we get what it is we had in the slide here. Now, the new products table is the source table, and the products table is the target table. When the match condition is the column product ID of the two tables. Now, if the match condition evaluates to false, that is not matched, then new records are inserted in the target table. If a match table evaluates to true, that is matched, then records are updated into the target from the source table. And if the records present in the target table do not match with those of the source table, not matched by source, then these are deleted from the target table. The last statement displays a record consisting of rows that were inserted, updated, and deleted as shown in the report. Okay, then we move on to the common table expressions. Now, the common table expressions are similar to a temporary result set defined within the execution scope of a single select, insert, update, delete, or create view statement. And a common table expression is a named expression defined in a query. Now, the CTE is defined at the start of the query and can be referenced several times in the outer query. A CTE that includes a reference to itself is called a recursive CTE. You remember what is recursion from what you learned in C and C++. The key advantages of CTEs are improved readability and ease in the maintenance of complex queries. Now, the syntax we use to create a common table expression is given below with the name of the CTE as the CTE definition. And the following code snippet retrieves and displays the customer count year-wise for orders present in the sales.sales order header table. Now, as usual, we are going to highlight, then copy, and let's meet in the query window. Okay, all done. Let me minimize the results window. Now, the purpose of this query is given in line 285. We're going to highlight and then execute. Once you click on execute, you get the results here. So you can see from 2011 to 2014 and the corresponding number of customers per year. Okay. Now, the following guidelines need to be remembered when defining common table expressions. One, CTEs are limited in scope to the execution of the outer query. Hence, when the outer query ends, then the lifetime of the common table expression is also going to end. And the reason being, you can see what it is we are saying here. The CTE is similar to a temporary result set. So once we get out of the scope, then it's actually gone. Okay. Next is that you need to define a name for the common table expression and also define unique names for each of the columns referenced in the select clause of the common table expression. It's possible to use inline or external aliases for columns in the common table expressions, and a single common table expression can be referenced multiple times in the same query with one definition. Now, multiple CTEs can also be defined in the same with clause. The following code snippet defines two common table expressions using a single with clause. We have two common table expressions being created here, and the first one is called CTE students, and its select statements are given here. The second one, you notice now we have this comma here. Okay, so this bracket is opened here, or parenthesis is opened here and closed here. Then we move on to the second one. Now this is the second CTE being defined as, then we have the statements being given here. Now we select everything from status record. Okay. Now basically what we want to do is to find out students who passed and failed. We don't have this table, so we're not going to execute this query. Now we are saying, assuming that some records are inserted in all the three tables, then the output may be as shown in the following figure. So we have the status of the students, and failed we have 2 students, and passed we have 2 students. Okay, we move on. We have the union operator. Now the results from the different query statements can be combined into a single result set using the union operator, and the query statements must have compatible column types and equal number of columns. The column names can be different in each statement, but the data types must be compatible. The syntax of the union operator is given below. We have the syntax given there: query statement, then union or query statement 2, where the first and second query statements are select statements. Now the following code snippet demonstrates the use of the union operator. Now this will list all the product IDs from both tables that match with each other. If you include the all clause, all rows are included in the result set, including the duplicate records. Okay, as given here. Now by default, the union operator removes duplicate records from the result set. However, if you use the all clause with the union operator, then all the rows are returned. Apart from union, the other operators that are used to combine data from multiple tables are the intersect and the except. Okay, now we're going to highlight this, and you notice now this one, the only difference is that this one has the word all. So you can just copy once, then you paste 2 times, then for the second you actually add the word all. Let's do that very quickly, and let's meet in the query window. All done. Now let me collapse the result window, then we can highlight all of them at once and see the difference. Okay, let's start with this one first. So we highlight the first one and click on execute, and you can see now this one is giving us 504 rows. If we execute the second one, it's actually going to give us a larger row count. So all the duplicates are given here. That is the difference between union and union all. Okay, we move right along. Let me save my work. The intersect operator. The intersect operator is used with 2 query statements to return a distinct set of rows that are common to both query statements. The syntax of the intersect operator is given below. Query, the first set of query statements intersect the second query statements, where query statement 1 and query statement 2 are select statements. And we have this example here. So we highlight this, copy, and let's meet in the query window. All done. We highlight these statements, then we click on execute, and you can see it gives us 266 rows. The purpose is given up here. Let's save our work and move right along. We have the basic rules for using the intersect. The first one is the number of columns and the order in which they are given must be the same in both queries, and the data types of the columns being used must be compatible. The results of the intersection of the production.product and sales.sales order details table would be only those product IDs that have matching records in the production.product table. Next is the except operator. Now this one returns all the distinct rows from the query given on the left except of the except operator, and removes all the rows from the result set that match the rows on the right of the except operator, and the syntax is given below. Now you notice that these operators, they are working in the same way. Okay, query statement 1 and query statement 2 are the select statements. Now the two rules to apply to intersect operator are also applicable for the except operator. We can highlight this, copy, and then we meet in the query window. Okay, we have the purpose of the statements below given in lines 320 and 321. We go right ahead and highlight this bunch of statements and click on the execute, and you can see we get the results given here. Okay, we move right along. Now, if the order of the two tables in this example is interchanged, only those rows from the production.product table which do not match with the rows present in the sales.sales order detail are returned. Okay, we could do that very quickly to see this. We highlight this, copy, then come down here and paste, then we swap these two. So this guy comes down here, okay, and this one comes up here. I'm using drag and drop. Then now you can see the current query is giving us 238 rows. Now if I highlight this and execute it, you can see now it gives us nothing. Okay, so what you're saying here is thus the except operator selects all the records from the first table except those which do not match the second table. Hence, when you're using the except operator, the order of the two tables in the queries is important. Whereas in the intersect operator, it does not matter which table is specified first. Kindly note that distinction. We move on to the pivot operator. Now, the brief syntax for the pivot operator is given below. Select non-pivoted column, then first pivoted column as the name of the column, second pivoted column as the name, as the alias. Okay, then you can do that up to the last pivoted column and you give us its alias from the select query that produces the data, then the alias for that particular source query. Pivot, then you can use an aggregation function. You specify the column which you would like to aggregate. For column that contains the values that will become column headers. In, you specify the various pivoted columns, then you give an alias for the pivot table, and you can use the optional order by clause. Okay, now brief explanation of the items used. Table source is a table or table expression. Aggregate function is a user-defined or built-in aggregate function that accepts one or more inputs. Value column is the value column of the pivot operator, and the pivot column is the pivot column of the pivot operator. Now, this column must be of a type that can implicitly or explicitly be converted into n-varchar. In, that is column list, are values in the pivot column that will become the column names of the output table, the list must not include any column names that already exist in the input table source being pivoted. Table alias is the alias name of the output table. The output of this will be a table containing all the columns of the table source except the pivot column and the value column. Now these columns of the table source, including the pivot column and the value column, are called grouping columns of the pivot operator. Now in simpler terms, to use the pivot operator, you need to supply three elements to the operator. We have grouping. Now the from clause, the input columns must be provided. The pivot operator uses those columns to determine which columns to use for grouping the data for aggregation. Spreading. Now here, a comma-separated list of values that occur in the source data is provided that will be used as a column heading for the pivoted data. Aggregation. An aggregation function such as sum average to be performed on the grouped rows depending on which operation you want to do. Okay. Now, the following code snippet is shown without the pivot operator and demonstrates a simple group by aggregation. As the number of records would be huge, the result set is limited to 5 by specifying the top 5 clause. Let's do this, copy, then let's meet in the query window. Now, this is done, and before we move on, we forgot to write the purpose of the previous query. Now, what we were trying to do here when we flipped this in the except operator, we wanted to display all the sales order details that don't have a matching record in the product table. Of course, that is why it didn't give us any results. Because if we did this, then we would be selling non-existent products and thus violating the integrity rules in our database. Okay, that's why it didn't give us any records. Now I've pasted this and the purpose of this is given. Let's highlight this and execute it. And you can see the results are given here. Okay. Now this is similar to what it is that we have here. Now the top 5 year to date sales along with the territory names grouped by the territory names are displayed. And the same query is rewritten in the following code snippet using a pivot so that the data is transformed from row-based orientation to column-based orientation. This works more or less like the transpose function in Microsoft Excel. Okay, so we're going to highlight this set of statements, copy them, and let's meet in the query window. Once we execute this, this is the expected results. Now the purpose of this statement is given up here, line 341. Now make sure you highlight, then you execute them, and you can see now what happens here. Okay, if you want to see the actual effect, you can actually highlight both batches, the one we had earlier and the one we've just pasted. Now click on execute, and you can see now here data is displayed row wise, and below here we can see now the data is displayed column wise. Okay, we save our work and move right along. Now, as shown in the figure, the data is transformed and the territory names are now seen as columns instead of rows, and this improves readability. A major challenge in writing queries using pivot is the need to provide a fixed list of spreading elements to the pivot operator, such as the specific territory names given in the code. It will not be feasible or practical to implement this for large number of spreading elements. To overcome this, developers can use dynamic SQL. Now, dynamic SQL provides a means to build character string that is passed to SQL server, interpreted as a command, and then this is executed. Okay. We move to the unpivot operator. Now, unpivot performs almost the reverse operation of pivot by rotating columns into rows. Unpivoting does not restore the original data, and unpivot has no ability to allocate values to return to the original detailed values. Instead of turning rows into columns, unpivoting results in columns being transformed into rows. SQL Server provides the unpivot table operator to return row-oriented tabular display from a pivoted data. When you're unpivoting data, one or more columns are defined as the source to be converted into rows, and the data in those columns is spread or split into one or more new rows depending on how many columns are being unpivoted. To use the unpivot operator, you need to provide the elements as follows: source column to be unpivoted, a name for the new column that will display the unpivoted values, a name for the column that will display the names of the unpivoted values. Okay. The following code snippet shows the code to convert the temporary pivot table into a permanent one so that the same table can be used for demonstrating the unpivot operations. Now we are going to highlight this. We copy and let's meet in the query window. And notice that this spans 2 slides, so you make sure you copy from here all the way to here. Okay, do that very quickly and let's meet in the query window. Now all done. We are starting from line 357 going downwards. Okay, now we are going to highlight all the way up to the bottom. Okay, up to line 382. So highlight this, scroll all the way to the bottom, then copy, sorry, not copy, but execute this set of statements. The result is given here, and this looks exactly to what it is that you have here. Okay. Now, grouping sets. Grouping sets operators allow you to group together multiple groupings of columns followed by an operational grand total row denoted by the parentheses. It is more efficient to use grouping sets operator instead of multiple group by with union clauses because the latter adds more processing overheads to the database server. Now, the syntax of the grouping sets operator is given below. Group by, then grouping sets, you specify the grouping set list, where the grouping set list consists of one or more columns separated by commas. Now, a pair of parentheses or brackets without any column name denotes a grand total. Now, the following code snippet demonstrates the use of the grouping sets operator. It assumes that the table student is created with the fields named ID, name, and marks respectively. Okay, so we have this set of statements, and the following shows the output of the code. So once you execute this bunch of statements, this is the expected results. Now we don't have the students table. We are not going to execute this. Here, the code uses the grouping sets to display the average marks for every student, and null values in the name indicates average marks for every student. Null values in both the ID and name columns indicate the grand total. Okay, now we can wind up. Let's look at the summary of what it is we've learned in these two in these sessions, both part 1 and part 2. The group by clause and aggregate function enable you to group and or aggregate data together in order to present summarized information. Spatial aggregate functions are newly introduced into SQL Server 2012. That is when they were introduced. A subquery allows the result set of one select statement to be used as a criteria for another select statement. Joins help you to combine column data from 2 or more tables based on a logical relationship between the tables. Set operations such as union and intersect help you to combine raw data from 2 or more tables. The pivot and unpivot operator help to change the orientation of data from column-oriented to row-oriented and vice versa. The grouping set subclause of the group by clause helps to specify multiple groupings in a single query. Okay. Now we've come to the end of the session. Have yourselves a nice time. See you in the next session, and God bless. Bye.